this lecture, we'll solve the problems on efficiency. A 220 volts, 12 kilowatts DC shunt motor has a maximum efficiency of 90%. So DC shunt motor means you should draw the DC shunt motor diagram. So this is the armature. The armature and field winding is connected in parallel to the supply voltage. The supply voltage is 220 volts, and as a maximum efficiency, yes, maximum efficiency is 90%. It should be equal to 0.9. The speed of 800 rpm. So n is 800 rpm. N is 800 rpm. When delivering 80% of its rated output. 80% of rated output means 80% of full load output. So this 12 kilowatts is the full load motor output. So 80% of the full load output is 0.8 into 12 into 10 to the power of 3. That should be equal to 9600 watts. And the percentage efficiency is just 0.9. Efficiency value is 0.9. Output power divided by input power into 100. Then input is equal to output divided by percentage efficiency. Output divided by percentage efficiency, that should be equal to 9600 divided by 0.9. So 10666.67 watts. Motor input is equal to 10666.67 watts. The total losses at 80% of full load. So we are calculating the output power at 80%. Then the total losses at 80% of the full load is equal to input minus output. So input power minus output power. What's the input now? The input is 10,666.67 minus the output power at 80% of the full load is 9,600. The value is 1066.66 watts. As efficiency is maximum at 80% of full load. So what is the condition for maximum efficiency? The condition for maximum efficiency is when variable losses is equal to constant losses. Variable loss is equal to constant losses. Then, so the total losses are 1066.66 watts. The variable losses plus constant losses is equal to 1066.66. But what is the condition for maximum efficiency? Is variable loss is equal to constant losses. Then variable losses is equal to constant losses is equal to 1066.66 divided by 2. So that should be equal to 48.4 sorry, that is divided by 2. Constant losses is equal to 2 5s 2 5s 1066.66 divided by 2 is 533.33 watts. 33 watts. And here that Ia square Ra is equal to 533.33 watts, because the armature copper loss is variable losses. And is there any armature resistance is given in the problem? The resistance of shunt field is 80 and determine the efficiency, right? The armature resistance, okay, you should calculate. ISH is equal to V divided by RSH. The supply voltage is 220 and RSH is equal to 80. That should be equal to 2.75 amperes. 2.75 amperes. Then I is equal to IA plus ISH, and IA is equal to I minus ISH. I minus ISH. So I am getting the losses, and this is a variable losses is 533.33. That is 533.33. So how can I get the line current? So this line current is IL, and the current which is flowing through this one is IA, and the current flows through shunt field winding is ISH, and ISH is equal to V divided by RSH. V divided by RSH. So the power output, so what is the power input is 10,666.67. 10,666.67, that is called the power input. So input is equal to V into IL. Now the line current I, that should be equal to IL is equal to, what is the power input? 10,666.66 divided by 220. So 10,666.66 divided by 220, that should be equal to 48.4 amperes. So substitute here, and 48.48 minus 2.75. So 48.45 minus 2.75, that should be equal to 45.78 amperes. 45.78 amperes. So this is about the armature current of a DC shunt motor. So armature copper loss is equal to Ia square into Ra. Ia is 45.78 whole square into Ra. The armature resistance we have to calculate. What is the variable losses? Yes, variable losses is 533.33 is equal to 45.78 whole square into Ra. 0.33 divided by 45.78 square. Then the Ra is equal to 0.2254 ohms. This is called the armature resistance. When the motor input current is 70 amperes, when the motor input current is 70 amperes, that is I value is 70 amperes, then Ia is equal to I minus ISH. The I value is 70, the ISH value is fixed now, that is what is the value of ISH is 2.75. that is equal to 67.25 amperes. 67.25 amperes. So after that, armature copper loss is equal to Ia square Ra 67.25 whole square into the armature resistance is 0.25. So I am getting as 1130.64 watts. This is about the armature copper loss. What about the total losses? The constant losses will be 533.33 only. So armature copper loss plus constant losses is equal to 67.25 whole square. So directly I am writing 1130.64 plus 533.33. Then finally I got it as 1663.97 watt. What is the motor input? So motor input is VI 220 into 70. That should be equal to 15,400 watts. So then the motor output, this is input, motor output is equal to motor input minus losses, total losses. This is the total losses. So 15,400 minus 1663.97, that should be equal to 13,736.03 watts. And finally I can calculate the efficiency, motor output divided by motor input into 100. So the value is 89.195 percentage. So that should be equal to 713.03 divided by 15,400 into 100. Once again, we will analyze the problem. See, a 220 volts 12 kilowatts. The 12 kilowatts is the full load output. The 220 volts is the input. Has a maximum efficiency of 90% at a speed of 800 rpm. When delivering 80% of its rated output, so it is giving 80% of rated output. The resistance of shunt field winding is 80 ohms. Determine the efficiency speed when the motor draws 70 amperes. The question is, determine the efficiency and speed when the motor draws 70 amperes from the main. So 70 amperes from the main. So from this, we are calculating, first of all, at the full load, what is the values? 80% of the rated output, what is the output, and then you can find the input value at 80% of the full load output. After that, find out the losses, and the maximum efficiency is given of 90%. At the maximum efficiency, variable losses is equal to constant losses, and after that, if you are getting the total losses divided by 2, that will give the variable loss and constant losses. That variable losses at 80% of the load, then after that I is equal to Ia plus ISH, and the line current is you can calculate from the input at the 80%. So this is at the 80% of the line current is 48.48 amperes only. Then calculate the shunt current value. Yes, anyway, shunt current is equal to V divided by RSH, and armature copper loss is Ia square into Ra. So after that, he is insisting to calculate the efficiency and the speed when the motor is 70 amperes. So the efficiency is calculated and the armature copper losses are changes. Why? Because it is a variable losses. Ia square R means it is a variable losses. 67.25 whole square into 0.25, and constant losses will be same. You can observe in any problem, the constant losses is same. So that's why we can assign the name as a constant losses. But if you go for the IA square, RA, that is called the armature copper losses. That is called the variable losses. As IA varies, definitely IA square RA is also varies. So you can calculate the motor input and motor output at 70 amperes, then you should calculate efficiency. So one more thing is also there, that is speed. So how can calculate the speed? V minus IA into RA. So this is 220 minus 45.78 into 0.25. This EB1, what is this EB1? EB1 is at 80 percentage of full load. 80% of the full load. Then I got it as 208.56 volts. 208.56 volts. And the EB2 is equal to V minus IARA, that is 220. Under full load conditions, what is the value? 67.25 into 0.25. Then finally I got it as 203.18 volts. So EB2 divided by EB1 is equal to N2 by N1 into 5.1 divided by 5.2. 5.1 divided by 5.2. So as a shunt motor, this one is constant. Directly you can substitute 203.18 divided by 208.56 is equal to N2 divided by, what is N1 speed? N1 speed is 800 RPM. Then calculate the N2 value, 779.36 RPM. This is the biggest problem and a long length problem. So you can solve this problem in this way. First of all, you should calculate the values, 80% of the load, 80% of the full load with the maximum efficiency is 0.9, and find out the losses. After that, variable losses is changing at a particular 70 amperes, and calculate the total losses, input power minus losses, that should gives the efficiency, and calculate the back EMF at 80% of the load, calculate the back EMF at 70 amperes, then EB2 by EB1 is equal to N2 divided by N1. Substitute the value, then you will get the solution. And coming to the second problem. What is this problem? A series motor takes a current of 180 amperes to develop 80 kilowatts. What is this series motor means? The line current and the armature current and the series field current all are same. So this is the line current, the armature current and series field current. So now I am applying a DC voltage. The DC voltage will be 500 volts and takes a current is IL is equal to 180 amperes. This is our armature current, and develops 80 kilowatts, means 80 into 10 to the power of 3. This is called the power developed by DC series motor. Okay, so what is the formula? EB1 into IA1 is equal to, what is the EB1 into IA1? Okay, this is EB1 into IA1. So you should calculate the EB1. So EB1 is equal to V minus IA1 into RA plus RSC. This you can treat as the IA1 and IL1. So what is the supply voltage? 500. What is the line current is 180 amperes. What is the armature resistance? Is 0.1 plus RSC is 0.04. And then finally you get as 474.8 volts. 471.8 volts. Okay, so when power developed, so what he is given, when power developed by DC series motor that should be equal to 40 kilowatts. See, if the output is reduced to 40 kilowatts, find the input and efficiency. Yes, now the power developed, that is EB2 into IA2. Calculate the EB2 value, V minus IA2 into RA plus RSC. This is 500 minus IA2 into 0.1 plus 0.04. So 500 minus 0.14 into IA2. Then the power developed by DC motor. Generally, power developed by DC motor. What is the formula? EB into IA. Then P1 by P2 is equal to EB1 by EB2 into IA1 divided by IA2. What is the P1? The P1 value is 80,000. It is reduced to 40,000. That should be equal to, what is the EB1 value? 474.8. What is the line current at the first one? Is 180 amperes. What is the EB2 value? 500 minus 0.14 into IA2 into IA2 into IA2. So finally, so this is 2, right? Yes or no? This is 2. And 2 into 500. 2 into 500 is 1000. 2 into 500 is 1000. Or 2 into 90. 2 into 90. So finally, I got the one equation. 500 I2 minus 0.14 into IA2 square is equal to 42372. So IA2 square minus 3571.42 IA2 is plus 305258.57 is equal to 0. From this, I got it as IA2 is equal to 87.61 amperes. What is the input to the motor? Input to the motor is V into IA2. So 500 into 87.61, that should be equal to 43,805 watts. Then finally find out the efficiency. Output power divided by input power. The output power for, yes, it is reduced to 40,000, right? It is a 40,000, but the input power is 43,805 into 100. That should be equal to 91.31 percentage. So input to the motor is V into IA2. Okay, so in this problem you can analyze easily. Power developed by the motor is EBIA. First find out the EB1 value and next find out the EB2 value. After that IA2 is the unknown quantity. So make a equation and substitute here. Then you will get the EB2 value. Okay, we'll discuss some of the problems in the next lecture. Thank you.